In order to simplify a rational expression, we're going to factor all numerators, factor all denominators, determine the non-permissible values by looking at what are those values that would make the denominator equal to 0, and then dividing out common factors. It is crucial that we do this step before we divide out, otherwise we can lose some of those non-permissible values in our canceling out process. In the first example, we have a monomial divided by a monomial. We cannot factor a monomial. And that brings us to step 3, determine the non-permissible values. So we can take a look at the denominator and see that if n is equal to 0, that whole denominator would have a value of 0. So n cannot equal 0. Now, we're going to treat this similar to reducing a fraction. So what is the largest number, other than 1, that will divide evenly into 6 and 9? And we can see that that's 3. So we're going to divide both of them by 3. And then we're also going to take a look at the variables. What's the largest variable that divides evenly into n and n squared? And we can see that it's n. So we're going to divide both the numerator and denominator by 3n. And when we do that, 6n divided by 3n is 2. 9n squared divided by 3n, so 9 divided by 3 is 3. N squared divided by n is n. So remember, when you're dividing powers with the same base, we're going to subtract the exponents. 2 minus 1 is 1. And then this is our simplified answer. I want you to pause the video, see if you can do the next one. Again, we cannot factor a monomial, so step 1 and step 2 are finished. Step 3, determine the non-permissible values. If we take a look at the denominator, we can see when x is 0, that whole denominator would be 0. And then if we just divide this, negative 12 divided by 4 is negative 3. And then 1x on top cancels with 1x on the bottom, leaving us with 2 x's in the denominator. Now, when we get to the third example, we can factor the numerator. So we're going to first check for a greatest common factor. We're going to remove that. And then it's really important that you look at the bracket. Are we able to further factor this? And because we don't have perfect squares here or here, there's nothing more we can do with two terms. The denominator is a monomial. We cannot factor that. So the non-permissible values, x cannot equal 0. Otherwise, my entire denominator becomes 0. Now, if we are multiplying fractions, we multiply the numerators, we multiply the denominators, and then we can reduce. So a quick way to do this, if we see that we're multiplying, is to recognize that we have a 4 on the denominator and a 4 on the numerator. Those are going to cancel. 4 divided by 4 is 1, leaving us with 2/3. So we can quickly get the answer. However, if we are adding two fractions, remember, we need a common denominator first. We're going to multiply to get equivalent numerators. We're going to add the numerators. The denominator stays the same, and then reduce. If you were to cancel these two, we're going to end up with 2/3, which is very different than 11/6. So if we're adding or subtracting, we cannot cancel common factors. If you're multiplying, quickly look, same on top, same on the bottom. Those are going to divide out. Here's one way that you can remember this, and it's a little gruesome. So if you're squeamish, maybe just ignore me for a second here. But if you imagine a person and we cut off the person's arm, and all of a sudden the blood begins to fly everywhere. Our little person makes it through, they are okay. But you're going to remember, if we are adding or subtracting and you try to cancel top and bottom, it's like you're ripping apart the body. It only works if you're multiplying. So when I take a look at this, I can see I am multiplying this monomial by this binomial. So I can cancel a monomial with a monomial. I'm going to divide x by x, leaving me with 1. A bracket on top has to cancel with an identical bracket on the bottom, and it's not there. We are not canceling this 5 with this 5 because that's like ripping apart the body. So we're going to put the binomial in brackets. The whole body stays together. So think brackets, body, intact. So we are fully simplified when we have 3 times x minus 5 divided by 5. And one way you can check to make sure that it is equivalent is you can choose any value for x. So I just went with 2 because it's easy to work with. So every time I see an x in the original question, I substituted in a 2, and then I worked out the value and simplified it down to negative 9/5. In my simplified expression, I also put in a 2 for x, and we can see that they're going to simplify down to the same value. If I were to mistakenly cancel those 5s, I'm going to be left with a negative 3x, which would be negative 3 times 2, negative 6, not the same value. So the body is staying intact. This is equivalent, and it is fully simplified because I can't divide my monomials by any further number, and there is no bracket in which I can cancel. Okay, in our next example, step 1, we cannot factor a monomial. We can factor a binomial, so we're going to check for a greatest common factor, and we can see that 3n will divide into both terms evenly, and so then 3n times n squared gets us back to the first term, 3n times -3 gets us back to the second term. In terms of the non-permissible values, or the restrictions, we're going to take a look at every factor that contains a variable. So we have 2 factors in this particular denominator. We're going to set both of them so they cannot equal 0, and then we're going to solve for n. So if n is 0, that becomes 0. As soon as we multiply by 0, my whole denominator is 0. Not allowed. We're going to then take the next factor, and again, we're algebraically going to isolate n. So we're going to add 3 to both sides. So we're going to have n squared cannot equal 3, and then we're going to square root to cancel out that squared. And because we're square rooting a variable, we're going to end up with both a positive and a negative root 3. So there are 3 non-permissible values in this question. If n is equal to 0, the denominator is 0. If n is equal to positive root 3, the denominator is 0. If n is equal to negative root 3, the denominator is equal to 0. And now we can see that an n in this monomial cancels with an n in this monomial. They're going to divide out, leaving us with 1. And this becomes our simplified answer in factored form. Now, it's also going to be equivalent if on the denominator we distributed this in to get 3n squared minus 9. That would be the same value. So this is factored form, but you could also distribute in if you wanted to. All right, so we begin by factoring the numerator and factoring the denominator. Remove the greatest common factor, check the bracket to ensure that we can't factor this further. We're then going to do the restriction. So we're going to look at the denominator, and every factor containing a variable we're going to set so it cannot equal 0. So if I get rid of this squared by square rooting, I can see that m cannot equal 0. And then in terms of this factor, I'm going to move over this 4. I'm going to divide out the 3. So eventually you're going to be able to see that m cannot equal positive 4/3. So we're moving this over, the sign changes to positive, we divide out the 3. So these are my 2 non-permissible values. Then we're going to take a look. Now I can see that I have a bracket in the numerator and an identical bracket in the denominator. These are going to divide out, leaving us with 1. So we're going to cancel those. 1m on top will cancel with 1m on the bottom, leaving us with 2 divided by m, and you can see why we had to do the restrictions right away. We still would have had that m cannot equal 0, but we would have lost our second non-permissible value. Factor the numerator, factor the denominator. By removing the greatest common factor, check, can we factor this further? If not, we are completely factored. Now, you're going to get faster at this as we go. We can see that in order for this term to not equal 0, x cannot be 0, and in order for this to not equal 0, x cannot be 3. If you can't tell, go into the margin of your paper and you're going to go 2x cannot equal 0, divide out the 2. X minus 3 cannot equal 0, add 3 to both sides. So you're going to speed this up as we go. And then we can see identical bracket in the top, identical bracket in the bottom, those will divide out. 1x on the monomial will divide out with 1x in the monomial, and we are left with a numerical value of 5/2. Okay, so what we're going to do is we're going to start to get into the habit of every time we see a binomial, we're going to bracket it. So we remember the body has to stay together. I can see that if x is 2, my denominator would be 0. So x cannot equal 2, and then we're going to also get into the habit of circling our non-permissible values or our restrictions. Now, I can't remove a greatest common factor from either the numerator or the denominator. I also don't have a difference of squares because neither the first term nor the second term are perfect squares. Okay, so we're down to the last step, which is simplify by dividing out common factors. Now, what I'm going to do is I'm just going to rearrange the order so that they're lined up with the denominator. So we've got a -2, which I put out front, and we have a positive x, which I just put here. Now we can see that they're close to looking the same, but they're not quite the same. So what I'm going to do is factor out a negative, or a -1 from that first bracket. So when I do that, and you can even check by redistributing, so a negative times a 2 would give me back that first term, and a negative times a negative would give me back that second term, and the denominator is the same. Now I've got 2 terms that are identical, so I can end up canceling those out, and the only thing we're left with is this -1, so my final answer is -1. So if you see a binomial and the terms are the same but both signs are flipped, so you'll notice -2, +2, positive x, negative x. Both signs have to be flipped. If they are, I would just recognize right away, we can pull out a -1, and then that is the final answer. All right, so again, we're going to begin by bracketing our binomials on the top and the bottom, and then we have to factor. Now, did you recognize that this is a difference of squares? So we're going to set up our conjugates, and then we're going to remove a greatest common factor from the denominator. This does not have a variable in it. So in terms of the restriction, I'm just going to say, what can t not be that would make this 0? And again, if you're not sure, go off to the margin, 1 minus t cannot equal 0, and then solve for t. So in this case, we can see t cannot equal 1. Now, are any of the brackets identical? And you're going to notice here we have a positive t, here we have a negative t, here we have a -1, here we have a +1. If the signs on both terms are flipped, that's where we can quickly recognize that those will cancel, and we're basically dividing out that -1. So then in terms of the answer, we're going to put that -1 in front. I don't need to write the 1 down. We're left with t plus 1 in the numerator, and we're left with an 8 on the denominator, and that is our final answer. All right, in our final example, we see a binomial, we're going to bracket it. We see a binomial, we're going to bracket it. We're going to check, is there a greatest common factor that we can remove? And there is for both the numerator and the denominator. Now, we're going to check the bracket. Is this able to be factored further? And in both cases, we can see that we have a difference of squares, a difference of squares. So we're going to set up our conjugates, and we're going to keep going. Once we are fully factored, we can do our non-permissible values. N cannot equal -2 in this factor. N cannot equal +2 in this factor. So we write it as n cannot equal positive or -2. And we can see that none of these brackets are the same on the top or the bottom, but we do have a 2 divided by a 2. So when I divide those out, 2 divided by 2 is 1, and then that leaves me just with those 4 factors, 2 on the top, 2 on the bottom, and this is factored form. So normally our question is going to ask us to leave it in factored form, but you also want to recognize that if we were to FOIL those out, this also is an equivalent answer. Again, we're not canceling the ends because these are 2 binomials. It would be like ripping apart that body.